Imagine standing on a vast plain, the horizon stretching endlessly, the world appearing flat beneath your feet. For ancient civilizations, from Vikings to Egyptians, the flat Earth was more than geography. It was a central belief shaping myths and defining humanity's place in the cosmos. Even in ancient times, some questioned the flat Earth, noticing clues that hinted at a different reality. These early thinkers, driven by curiosity, began a journey that would eventually overturn centuries of belief. In Mesopotamia and beyond, people saw the Earth as a flat plane beneath a dome of stars, a view echoed in cultures worldwide. Myths placed the Earth on turtles or elephants, reflecting humanity's first attempts to explain the unknown. These early models brought comfort and order, placing humans at the center of a mysterious universe. The Babylonians meticulously charted the skies on clay tablets, predicting eclipses and creating calendars. Their careful observations laid the groundwork for future astronomy, showing the power of curiosity even within limited frameworks. The Egyptians imagined Earth as a flat plane, with the sun god Ra sailing across the sky and the Nile reflecting celestial rhythms. Their cosmology, woven into daily life, reveals how nature shaped ancient understanding of the universe. In Greece, philosophers like Anaximander challenged the flat Earth, proposing new models based on observation and reason. They suggested Earth might be a three-dimensional object, not just a flat plane. Their willingness to question tradition sparked a revolution in scientific thought. Aristotle observed that Earth's shadow on the moon during eclipses was always curved, evidence for a spherical Earth. He also noted that travelers saw different stars as they moved south, impossible on a flat plane. These logical deductions helped solidify the idea of a round Earth in ancient thought. Eratosthenes used simple tools, a stick, a well and math, to calculate Earth's circumference with remarkable accuracy. His experiment proved not only that Earth was round, but also revealed its true scale. As the idea of a spherical Earth spread, explorers dared to venture beyond the horizon, guided by new tools and knowledge. Each successful voyage chipped away at the flat Earth myth. The world was opening up, revealing itself as a globe. Ferdinand Magellan's expedition set out to circumnavigate the globe, facing storms, mutiny, and the unknown. After 3 years, his crew returned, proving the Earth was round and finite. Their journey marked the triumph of curiosity and evidence over ancient belief. Magellan's voyage, really marked a turning point in human history, a definitive nail in the coffin for the old flat Earth theory. The Renaissance, that remarkable period of intellectual and artistic flourishing, was in full swing, and with it came this renewed interest in classical learning and a real thirst for scientific discovery. The world, no longer seen as static and unchanging, was suddenly becoming a place of wonder, ripe for exploration and understanding. The printing press, invented just a few decades before Magellan's voyage, played a pivotal role in spreading these new ideas far and wide. Books, once rare and expensive, became more widely available, which meant knowledge could travel and old dogmas could be challenged. The heliocentric model of the solar system, proposed by Nicholas Copernicus, began to gain traction, placing the sun, not the Earth, at the center of the universe. This shift in perspective, from an Earth-centered to a sun-centered cosmos, was nothing short of revolutionary. It challenged not only our understanding of the universe but also our place within it. The Earth, once considered the center of all creation, was now seen as just another planet, orbiting the sun, along with its celestial siblings. The Renaissance, fueled by a spirit of inquiry and a rediscovery of classical knowledge, set the stage for a scientific revolution that would sweep across Europe and beyond. The flat Earth theory, once a dominant belief, was quickly becoming a relic of the past, replaced by a more nuanced and accurate understanding of our planet and its place in the cosmos. As the Renaissance gave way to the Age of Enlightenment, a new generation of scientists and thinkers emerged, armed with increasingly sophisticated tools and a burning desire to unravel the mysteries of the universe. Among them was Galileo Galilei, an Italian astronomer, physicist, and engineer whose groundbreaking observations would, honestly, forever change our view of the cosmos. Galileo, after hearing about the invention of the telescope in the Netherlands, decided to build his own. With this new instrument, he pointed it towards the heavens, becoming the first human to observe the moon, planets and stars with such clarity. His discoveries were nothing short of astonishing, challenging long-held beliefs, and ushering in a new era of astronomical observation. He observed craters and mountains on the moon, shattering the old notion that celestial bodies were perfect, unblemished spheres. He discovered 4 moons orbiting Jupiter, providing evidence for a celestial system that was not centered on Earth. He also observed the phases of Venus, which further supported the heliocentric model of the solar system. Galileo's observations, meticulously recorded and shared with the world, provided irrefutable evidence for a universe far more complex and dynamic than anyone had previously imagined. His work, though met with resistance from those clinging to old dogmas, helped solidify the heliocentric model and ushered in a new era of scientific inquiry, one based on observation, experimentation, and the pursuit of truth through empirical evidence. The flat Earth theory, once a seemingly unshakable belief, had now been definitively debunked, relegated to the annals of history as a testament to the evolving nature of human understanding. Fast forward to the 20th century, a period marked by unprecedented technological advancements and a relentless push into the unknown. The space age, which kicked off with the launch of Sputnik in 1957, ushered in a new era of exploration. This time, the most definitive evidence yet against the flat Earth theory came not through complex deductions or philosophical arguments, but through the sheer power of visual confirmation. Imagine this. It's December 24, 1968. The Apollo 8 mission, the very first manned voyage to orbit the moon, is preparing to loop around the lunar far side. As the spacecraft emerges from the moon's shadow, the crew is suddenly greeted by a breathtaking sight: Earth, a vibrant blue and white sphere, rising above the desolate lunar horizon. This iconic image, known as Earthrise, really captured the imagination of the world. It showcased the beauty, fragility, and undeniable sphericity of our home planet. Here, suspended in the vastness of space, was irrefutable proof of what ancient astronomers had long deduced. The Earth was not a flat disk, but a vibrant sphere, teeming with life and enveloped by the blackness of space. The Apollo missions, culminating in those famous first human steps on the moon in 1969, provided a treasure trove of images and data, further cementing the reality of a spherical Earth. These missions, driven by human curiosity and the pursuit of scientific knowledge, offered a perspective shift unlike any before, allowing us to see our planet from a distance, no longer bound by the limitations of our earthly perspective. The legacy of the space age extended far beyond those early missions. Satellites launched into orbit around Earth became our eyes in the sky, providing a constant stream of data and imagery that, honestly, revolutionized our understanding of our planet. These technological marvels, equipped with sophisticated sensors and imaging systems, allowed us to observe Earth on a global scale, tracking weather patterns, monitoring environmental changes, and mapping the Earth's surface with unprecedented accuracy. Imagine the power of these tools. Satellites capable of tracking hurricanes as they form over the ocean, predicting their path and intensity, and, helping to save countless lives. Sensors monitoring deforestation in the Amazon rainforest, providing crucial data for conservation efforts. Imaging systems mapping the Earth's topography, revealing the intricate details of our planet's surface, from towering mountain ranges to vast ocean depths. These technologies, built upon centuries of scientific inquiry and technological advancement, provide us with a comprehensive view of our spherical planet, a view that was just unimaginable to our ancestors who gazed up at the night sky and pondered the nature of their world. The data collected by satellites is not a matter of belief or interpretation. It's a testament to the power of observation, measurement, and the relentless pursuit of knowledge. The flat Earth theory, in the face of such overwhelming evidence, simply cannot hold up. The world we inhabit, as revealed by satellites and the technologies they enable, is a dynamic, interconnected sphere, a testament to the power of science to unravel the mysteries of our universe. But the evidence for a spherical Earth goes beyond even the awe-inspiring images from space and, the trove of data collected by satellites. The very laws of physics, the fundamental principles that govern the behavior of matter and energy in our universe, point towards a spherical Earth. Gravity, that invisible force that binds us to our planet and governs the motion of celestial bodies, plays a crucial role in shaping the objects in our universe. Gravity pulls equally from all directions towards the center of an object. For a large celestial body like Earth, this inward pull of gravity shapes it into a sphere, which is really the most stable configuration for a massive object. Imagine trying to create a giant cube-shaped planet. The immense pressure from gravity would cause the corners to collapse inward, eventually shaping the object into a sphere. This principle of gravitational equilibrium is not limited to Earth. It actually governs the shape of stars, planets, and even large moons throughout the universe. The Sun, a giant ball of hot gas, is held together by its own gravity, its spherical shape a testament to the immense forces at play. Jupiter, the largest planet in our solar system, exhibits a slightly flattened sphere due to its rapid rotation, but its overall shape is still governed by gravity. The flat Earth theory, in defiance of these fundamental laws of physics, simply cannot hold water. Our everyday experiences, from objects falling towards the ground to the curved horizon we observe at sea, are all influenced by gravity, a force that shapes the universe around us and provides further evidence for a spherical Earth. The debunking of the flat Earth theory serves as a powerful reminder of the importance of scientific thinking, of relying on evidence and reason, not dogma or blind belief. The journey from a flat Earth to our modern understanding of a spherical planet, orbiting a star in a vast and ever-expanding universe, is a testament to the power of human curiosity, the relentless pursuit of knowledge, and the willingness to challenge even the most deeply held beliefs in the face of evidence. The same scientific principles that allowed us to disprove the flat Earth theory, the same tools of observation, measurement, and logical deduction, are essential today as we grapple with some of the most pressing challenges facing humanity. Climate change, a phenomenon driven by human activity and supported by overwhelming scientific consensus, requires us to rely on evidence, not ideology, to understand its causes and consequences and to develop solutions for a sustainable future. The lessons learned from the flat Earth debate serve as a cautionary tale against the dangers of misinformation, the spread of unsubstantiated claims, and the rejection of scientific consensus. In an age where information, both accurate and false, spreads at an unprecedented rate, it is more important than ever to cultivate critical thinking skills, to evaluate sources, and to ground our understanding of the world in evidence and reason. The legacy of those who dared to challenge the flat Earth theory, from ancient Greek philosophers to modern-day astronauts, is not just a more accurate view of our planet, but a call to embrace the scientific method, to approach the world with curiosity and a critical eye, and to never stop questioning, exploring, and seeking truth through the power of evidence and reason. So we've journeyed from a time when the Earth in the minds of our ancestors was a flat disk, the center of all creation, to our modern understanding of a spherical planet, hurtling through the vastness of space. It's been a journey fueled by human curiosity, a relentless pursuit of knowledge, and the courage to challenge long-held beliefs in the face of evidence. The story of how we debunked the flat Earth theory is a testament to the power of the scientific method, our most reliable tool for understanding the universe and our place within it. It's a story that continues to resonate today, reminding us that knowledge is not static, but rather an ongoing process of discovery, refinement, and at times, a complete overhaul of our understanding. But the allure of a spherical Earth extends beyond its scientific validity. There's a certain poetic beauty to it, a sense of interconnectedness and shared destiny that arises from knowing we all inhabit this fragile sphere, hurtling through space together. The images of Earth from space, those breathtaking vistas of blue oceans, swirling clouds, and continents painted in hues of green and brown, have captured our collective imagination, reminding us of the preciousness of our home and the importance of protecting it. The realization that we live on a sphere has fostered a sense of global citizenship, a recognition that our actions have consequences that extend far beyond our immediate surroundings. It's a perspective shift that has fueled international cooperation, environmental awareness, and a deeper appreciation for the interconnectedness of all life on Earth. The debunking of the flat Earth theory wasn't simply about correcting a misconception, it was about embracing a way of thinking, a commitment to evidence and reason over dogma and blind belief. It's a commitment that extends far beyond the shape of our planet, guiding us as we navigate the complexities of our world and grapple with the challenges that lie ahead. In an age of misinformation and rapid technological advancement, the principles that guided us away from the flat Earth are more crucial than ever. We must be critical consumers of information, questioning sources, evaluating evidence, and remaining open to new ideas while grounding our understanding in scientific consensus. The spirit of exploration that drove Magellan to circumnavigate the globe, that propelled Galileo to point his telescope at the heavens, that led us to the moon and beyond, is the same spirit that drives us to unravel the mysteries of the human brain, to explore the depths of our oceans, to search for life beyond our planet. It's a spirit that reminds us that the quest for knowledge is never ending, that there will always be new horizons to explore, new mysteries to unravel, new truths to uncover. So, as we marvel at the beauty of our spherical Earth, let us also embrace the legacy of those who dared to question, to explore, to seek truth beyond the confines of our limited perceptions. Let their story inspire us to approach the world with open minds, a thirst for knowledge, and an unwavering commitment to evidence and reason, for it is in this spirit of inquiry that we will continue to push the boundaries of human understanding and create a brighter future for all.